All right, next one, electron affinity. Electron affinity is a little bit weird, okay? Electron affinity, it's going to be the energy released or gained when an electron is added to a gaseous atom. So what you'll notice is that there is nothing about size here. It's just about that atom all by itself gaining an electron and how much energy it has to give up for it, or how much energy it is going to gain. Okay, so does not matter right? Size does not matter here. Okay? So, if we move to the right, right? If we move to the right, the effective nuclear charge is going to increase. Okay? So, the anion is getting kind of more and more stable, right? We have more, those electrons that are at the valence electrons, they're going to be more stable to add an extra electron because it's seeing more of those protons. So if the effective nuclear charge increases, really it's getting closer to that full octet, okay? So as it does that, the anion is going to be more stable, so therefore our electron affinity, I'm going to abbreviate it as EA, our electron affinity is going to increase. Okay? What about as we go down? As we go down the periodic table, is there any change in the effective nuclear charge? There's no change in the effective nuclear charge. And we already said that size doesn't matter for the electron affinity. So if there's no effective nuclear charge change, and we don't care about the size, electron affinity has no trend. Okay. So again, we want to be able to rationalize all of these periodic trends using our fundamental forces. Okay. All right, last one, electronegativity. Electronegativity, it's the measure of an atom's ability to pull electrons from a bonded atom. It's the ability of an atom to pull on bonded electrons. Okay? So, this one is probably one you remember from last year, but as we move right over to fluorine, right? Fluorine is the big pig, it's going to increase. And as we move down, it's going to decrease. Let's see if we can rationalize that. Okay? So as we move right across the periodic table, right, effective nuclear charge increases. And the atomic radius decreases. So the effective nuclear charge increases. The atoms, right, atomic radius is smaller, so the atoms are able to come closer together. Okay, so that means that the protons on the nucleus of one atom is going to be closer to the electrons of the other, and it's got a higher effective nuclear charge. So that means that our electronegativity, I'll say En, my electronegativity is going to increase. Okay, fluorine's the big pig, that's why. All right, now as we go down the periodic table, effective nuclear charge, no change, right? So that's not helping pull on any electrons. And as we go down, the atomic radius is getting larger. So as the atomic radius gets larger, that means that the protons from one atom, right, my protons here, it's getting farther and farther away from the electron cloud over on this one. If it's farther and farther away, that means that my electronegativity, it's going to have a harder time pulling on those electrons. So my electronegativity is going to decrease.